So let's summarize this data. Since we've already kind of developed a set of summary statistics, we could just copy and paste from a previous tab to get those in here. Clean this up just a little bit to make that all in one cell by format, text wrap, wrap. That's a little better. And then I'm just going to borrow the summary statistics from, let's say, the sleep tab here. These guys here. So I can copy and paste them. And again, this works because when I did the formulas, I said, look at everything in column A. And all that was in column A were those numbers there. If we don't set up the formulas right, that doesn't work. And again, the formulas are, oops, count to do the count, min to get the minimum, max for the maximum. Range is always max minus the min. Mean is average. Standard deviation is stdev.s. And again, if you're watching this online, I'll put a link to this spreadsheet in the comments, in the description. And then we have our quartiles, which we'll get to in a minute. So let's see, just clean this up a touch. Let's make a histogram. So histogram, easy in Google, highlight your data, insert your chart. There's my insert chart button. All right, so this person seems like an outlier, right? They're way out from everybody else. And Google picked some interesting numbers there. So let's clean that up. It looks like they picked a width of 30 minutes. That seems okay, maybe. So histogram, customize, instead of auto, let's make it 30 to clean up those numbers. So often what I'll do is I'll look at what Google guessed at and I'll just clean up the number a little bit, right? You've seen me do that a few times now. I have a lot of empty buckets because I have a big gap between the maximum and the next highest number, right? The maximum was 300 minutes. That's a lot. How many hours is that? 300 divided by 60. Oops. Done that in my head. That's 5 hours. Average daily commute of 5 hours. So sometimes when we get something that's that unusual, let's see, how many standard deviations is that above average? Let's check that. So to calculate that, let's do it on a piece of paper. Back away. And I just want to borrow these summary statistics. So we have to decide. Sometimes when you get something that far out compared to everyone else, you just say, let's not look at that number. Let's ignore it for now. Come back to it later, maybe. So let's add this to a new page. All right. So I want to know, how unusual is this? Right? It seems unusual. It's pretty far from the rest of the pack. And so far, the only way I have to measure how unusual something is to count how many standard deviations it is above average. Okay, well, we can do that. So the quick way to do that for a single number is to take the number, that would be an x, subtract it from the mean. That gives me the deviation. If I then take that deviation and I divide it by the standard deviation, that's going to count how many standard deviations are in the standard deviation. So this will count for me. So for this one, I want to take what is 300 minus 25 point, let's call it 25.5 for the mean. And the standard deviation is about 35. Let's just call it 35. Or I guess since I went one decimal there, I'll call it 35.4. So I want to know what that is. All right, calculator. So I can do that here. So what is parentheses 300 minus the mean? That gives me the deviation, close parentheses, then divide by the standard deviation. So that number right there, the 300, is almost 8 standard deviations above average. Oh my gosh. What did I say was usual? Usual is to be about 2, maybe 3 standard deviations from the mean, right? So that person right there is, that said 300 minutes compared to everybody else, 4 standard deviations about there, 5, 6, 7, 8. This would be 8 standard deviations to the right of the mean, right? That's way out there. So that's super unusual. So when you have outliers like that, one of 2 things, maybe 3 things is true. This person is just really unique. They really drive that on average every day. Wow. Or there's an error. Oops, they meant to put 30. Okay, I don't know. So oftentimes with data like this, I say, let's just take that out so we can better look at the rest of the data. So it's still in my original data set, but I'm just gonna delete it. Because it's that standard deviation, being 8 standard deviations away is pretty wild. It's pretty far out there. All right, now that's gonna change all my calculations since I pulled that out, right? I have 1 less number. The max is now 120, which is only around 3.5 standard deviations above average. The standard deviation is now 26 instead of 34, a little bit better. All right, let's try to graph this again. So highlight the data. Okay, so this is a little bit better. Notice that this has a big tail out to the right. Most people don't travel far, right? Generally, we live near where we work or where we go to school. And when I asked about commutes, when I first started asking that question, it was to on-campus students. Now all of my students are online and I have no idea where they were. So how they interpreted commute time, I'm not really sure. Commute where? All right, so here's my data. Let's see, here we're jumping by 11. So I'm gonna clean that up and let's jump by 10. So histogram, instead of auto bucket size, let's go with a bucket size of 10. Yeah, that looks all right. We have how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 columns. One of them's empty. That's not too bad. Remember earlier I said with a histogram, we want between 6 and 20 groups. Too many of that, it's too painful to look at. Too few is not that useful. But let's go with this. I think this is all right. Okay, so not the best titles. I guess I will clean that this time. I don't need it to say histogram. It's obviously a histogram. Average daily commute time in minutes. Average daily commute time in minutes. I guess that's okay. But I do need a label over here. That would be the vertical, and this would be number of students. Okay. And that's all I need. Let's draw on it. All right, so here's my graph, and then I need to see some of my summary statistics. Oops, I covered them up. Now I'm just looking at these first 6. All right, so standard thing I like to do on a histogram when I'm thinking about what the data means is I like to mark off where's the mean. So my mean is about 24, roughly. 23.55, so here's 20, there's 30, so about 24, I'd say it'd be around here. So that's my X bar. And then I like to think about the standard deviation. So just to kind of round things out a little bit, I'm going to say this one's about 25 and this one's about 25. It just makes it easier to count. Otherwise, I have to whip out a calculator to get those. So from 25, if I jump 25 to the right, that's going to put me at about 50. So that would be 1 standard deviation to the right. So I'm just going to make a new number line down here. And at about 50, that's 1 standard deviation to the right. The mean, remember, that's no standard deviations. Oops. All right, so as far as counting standard deviations, that's a 0 at the mean. 2 standard deviations to the right would be about 75. So that's about right here-ish. So that's 2 standard deviations to the right. 3 standard deviations to the right would be another 25 or 100. So out here. That would be 3 to the right. Going the other way, 25, I'm estimating that, and that is 25. That would put me at 0 over here. So that would be 1 standard deviation to the left. And 2 standard deviations to the left is just negative 25. That's off the charts, right? That's not even, you can't even talk about that anymore. And usually what we find is that within 2 standard deviations, so from 2 standard deviations to the left to 2 standard deviations to the right, I expect about 95% of the data to be in there. Right, so let's just look at our data again to double check that. So again, I'm estimating 2 standard deviations to the right to be about 75. It's actually whatever X bar is plus 2 times the standard deviation. And we can calculate that on the spreadsheet. So I'm going to add that in here just for fun underneath here. So I want the mean plus 2 standard deviations, 2s. And so I can just go equals mean plus 2 times the standard deviation. Click. So I was calling it 75, it's almost 77. So that's like the upper end of what's normal. So anyone has a commute time higher than that is unusual compared to the rest of the crowd. And then 2 standard deviations to the left, remember that's a negative number. You can't have negative minutes, but I'll calculate it anyway. The mean minus 2 standard deviations equals, again, the mean minus 2 times standard deviation gives me negative 26, might as well be 0. So the usual crowd is people that don't have to commute. Maybe they work from home. Maybe they don't work. Maybe they do school from home. All the way up to 76.8, I think it was. So that would be up to this last 75 here. So that's 128 of them. Let's highlight those. This is the usual crowd. And these people, compared to everybody else, their commute time is a little bit long compared to everybody else. Maybe because we have so many people that didn't have to commute, 0. Right? They live where they work, or they live right by school. So I counted here, what was it, 122? Eek, I forgot. 128, okay, out of how many? 138. So if I take 128 and divide by 138, I get almost 93%. So let's rewrite that as a percentage. So about 92.75 students. What do we do? Have commute times. Commutes within 2 standard deviations of the mean. Just to move it out of the way is what I calculated there. And often with the data, we don't need an exact value for that. We can just kind of eyeball it based on the histogram, but we can calculate it exactly if we need to. And so did we identify any outliers, any numbers that are unusually small or unusually large compared to the rest of the group? And the answer is yeah. All of these above 75, these are all unusually high commute times. So maybe I'll highlight those in red. Okay, so let's see. We are, I think, a little more than halfway done with this section. So I keep saying I would talk about that those other few percentile summary statistics. We haven't talked about those yet. So I guess it is time for that. I think I want to go back to a different data set to do that. I think I'm going to do it with the sleep one. Yeah, okay, give me 1 sec.